Welcome students to my lecture number 59, which is in fact the second part of the machinery selection and management of farm machines. We in the first part we have talked of how we should have for a 20 hectare farm, and if you are thinking of a certain set of machines, what should be the concept behind, how the machines should be selected from available machines, and depending upon their capacity and depending upon what crop rotation I take and cropping intensity we are intending to have. As I said, that some of the equipment which we did not include there could be that irrigation, for irrigation you can have equipment, for transportation you can have equipment. But then when we are talking of managing this and we are talking of the cost, now I have taken here a problem through which we will just calculate the different costs of the machine, taking into consideration various aspects of the machine, the ownership cost and then the timeliness cost and the total cost, variable cost, etc. And then how do we find out what should be the actual cost of owning a particular machine, irrespective of which machine is. We have not taken the cost of each machine which we took in the earlier part, but here we will take one particular type of machine and then where we will go into details of these calculations. So, let us go by the slide which I have. Now, depreciation methods, suddenly I have put a depreciation method. Why? Because when you have the equipment, one important things that should be kept in mind is that the depreciation of the equipment starts from the day one. So, after you have purchased and you have started using it, then it will start depreciating. Now, it does not get depreciated in one day as such, as I say, but definitely you can say the depreciation starts from the next day. So, after 1 year, what will be the cost of this? After 2 years, what will be the cost of this? After 3 years, what should be the cost and its condition, etc., because then everything has to be looked into. Now, various methods are there. How do you find these costs? So, some of the methods which are used very you can say available in literature and people use depending upon their suitability as and when required. We have just listed those methods here. Say straight line method gives constant amount each year. Now, this is one method which is very widely used, and on a thumb rule basis one can use it and find out. But then see the declining balance method gives depreciation as constant % of the remaining value at the beginning of the year. This is another way of looking at it. Sum of years digits method charge higher depreciation in early years of the useful life. Yes, you can think of, because early years definitely higher depreciation as it goes, definitely it will lesser and lesser. So, sinking fund method has based on compound interest and then advantages for use with a planned replacement internal policy, depending upon what you think. So, these are the 4 methods which are generally found out for calculating the depreciation of the equipment that you have thought of. And in the when we are actually talking of the remaining book value of the machine at the end of a given year, then the initial cost minus the total depreciation amount till that year is the book value. So, if we plot here, now here in this particular diagram what I have shown is the machine book value here and the number of years on this side here. So, we find in million rupees here, just for international audience, we have converted 1 rupee so much of dollar as on 23rd of July 2018. Now, this is just an idea for the larger audience outside. Those who understand rupee is fine, but those who do not understand, for that we have put in million rupees here. And the behavior of all these methods are given here to understand. It is not, I did not go into details of the discussion of how it happens and all. It is very simple to understand. If you follow any one of the methods, you can calculate what exactly is, and then plot over the period from 0 to 10 years depending upon what is the equipment. We do not find that any equipment lasts more than 10 years. Well, you may say that there are equipment which are some of the equipment which can be used for 15 years, 20 years, but then depending upon their condition and the repair maintenance and then other parts, replacement of the parts, etc., you can use a machine. But we do not talk of that, because if you go into that sort of a carcass, I tell you that you will definitely fall into problem, because repair and maintenance will keep on adding up here and there, and it will create very neck pain until so far as the success of the system is concerned. And that is why we would consider the relevant and the most effective use period of the equipment. And that is why a 10-year period with the number of hours of each one of them are given the standard books, particularly the ASA standards, ASAB standard now what we call, and from there we all use for our cost calculations, etc., one selection of machines. Now, let us see, I have put as a problem, but then we will get into the details of this later. A farmer is using 2.5 meter header or on combine to harvest wheat at a speed of 2.5 kilometer per hour. The wheat is yielding 3.2 megagram per hectare. Losses proportional to area total to 32 minutes per hectare are primarily due to the unloading grain from the combine. Neglecting any other losses, now we need to calculate say for example, the field efficiency and the field capacity on area basis and on material basis, total material which is produced. Then rotary power, how much is the rotary power required? Then the specific annual ownership cost and the total annual ownership cost of the machine which you have. Total operating cost per hectare, excluding timeliness of cost. Now, you remember this, assume the all the other necessary data. Well, we need to understand what necessary data we need to take from the table, etc. So, that is why this has been written. Now, as I said, we are talking of a combine. So, this is the combine which has been given here, and using this, how do you proceed? What are the methods that we adopt and how do you adopt them? First, determine the field efficiency and field capacity on area and material basis. This is first thing. How do you, what formulae we already know for this? Well, we are talking of the field capacity on area basis. Now, this is known to you already from previous knowledge which we have discussed. We are talking of the width of the machine, then we are talking of the speed of the machine here, and this constant will give you how much is the hectare per hour. This is given hectare per hour from the data which has been given. Now, field efficiency, we know that field efficiency will have different components. It will think of what is the actual work done and the theoretical work done, and then the losses which have taken place of various kinds of those. For example, we are talking of fraction of the implement with actually used, then the time losses that are proportional to the area, the time losses are proportional, not proportional to the area. There could be time losses which are maybe header loss and things like that. So, here if you talk of these, you find something like this, that is T tau T here is talking of the total, and Kw is talking of the fraction of the implement with actually used. So, with field efficiency given by this expression here, the total time or the theoretical time you can think of. So, these are the times actually. Now, we have to think whether how best we can estimate these parts, that is essential. Now, you see here that we have talked of 0.625 hectare per hour is the capacity, theoretical capacity of this, which is FCT, which we are calling. Now, then with use of this, what we get TE or TET here, which is the effective operating time. Effective operating time comes to this 1.6 hours. It's just if you take inverse of this, you will get this value. And then the efficiency, here we are talking of the time loss that are not proportional to area as equal to 0. So, with these, then you are getting that efficiency is about 0.75. That means, efficiency is over 75%. field capacity on area basis, that you have got already actual capacity. Here you got about 0.7 with this field efficiency you get this value. So, the field capacity on material basis is that crop yield has to be multiplied with this. So, we know that this is the hectare and this is the mega gram per hectare So, on a field capacity on a material basis comes out to be this so much of mega gram per hour, and this has got 0.625 hectare, which has come to about 0.47 hectare per hour. So, this is the way we try to understand. Now, you need to look into these expressions while considering the machine. The various aspects which we have given in this particular problem need to be very carefully understood, and then the formula to be used and the answers to be produced out of that. Okay. Now, let us come to the determination of rotary power requirement and power requirement for the engine. Yes, it is very essential to know how much of rotary power will be required and what should be the requirement of the engine's power, actually total power of the engine, which will be the main power and which will deliver to other units of the combine which is under consideration. So, here we find that the P rotary is given as A plus BW plus CFC MT, where P rotary is kilowatt, the width W is the header width, then FC is theoretical field capacity on material basis, and ABC are the specific constants which we have got from the SAE D 497 data, this thing. Now, hence A is 20 kilowatt, B is 0 kilowatt per meter, and C is this for combine for small grains. Now, this is the data which we have taken from this here, and it is worth mentioning here when we are trying to find out the total rotary power. Now, using this formula here, we know that CMT is given as this into this, which comes out about 2 megagram per hour. Now, then the rotary power using this equation can be simply found out to be the P rotary is equal to 27.2 kilowatt. Now, there are certain considerations here. Now, this is the power required for the rotary portion only, but then you need to look into what should be the power, total power to be taken, and the power of the engine. Here this is the one which is required. Now, once you go for this, now there is something, a note given which is essential, and designers must look into it. Estimate is for average condition, this is for an average condition, but then actual power requirement could be 50% higher or lower as given in this. Now, there is a data, I will show you the data wherein we have the various aspects which are given and the designer can choose from there. So, this actual power could be 50% higher than this, and it is always better to have a higher power, because you do not know how much will be the requirement and what sort of eventualities which will come in the when the machine is under operation. So, therefore, we can simply double this, and you think of about 55 horsepower or of the engine could be taken. Now, another power requirement is grain bin unloading. Now, for unloading you will find, we will show in the table there, that for unloading also you require certain power. So, considering the rotary power and the other exigencies, including the power for unloading of the grain bin, then you will require another 30% of that. So, virtually you require a power which can be as high as about 70 kilowatt. This is what we have worked out on the basis of this. So, roughly we can think that about 70 kilowatt of engine or the combine is required for getting the rotary power and all sorts of power that will be required. We can say that if you do not have a 70 kilowatt engine, maybe about 80 or 90 kilowatt combine is available, you will have to choose. If it is a 60 kilowatt combine, then this will not serve the purpose. If it is a 80 kilowatt or 100 kilowatt combine, then you will have to take that, because this is the requirement basis. You cannot, if you think that is about 70 kilowatt and we can do with only 65 kilowatt, then I think that we will be in trouble at some point or the other. And therefore, if the requirement is this for the engine and it is available about 80 kilowatt, fine, I think we should take to be with a certain factor of safety. Now, determination total operating cost per hectare excluding timeliness cost. So, now if you exclude the timeliness cost here, the determination total operating cost per hectare works out to be. Now, certain assumptions, when we want to do this, we have to have certain assumptions. What are those assumptions? Well, these assumptions could be working hours of the combine. Well, you see that these machines, in fact, if you see in reality, although we have taken about 8 hours per day, but in reality these machines start from early morning until late evening, and about 14, 15, 16 hours we have seen to be used. Even in the nights they use lights and then use these machines. But then for the calculations and for a general assessment and understanding of this problem, I think if you take 8 hours per day and 200 hours per year for the use of this machine, in fact, although these are the standard values which we say that they are used much more than that, but then for this particular problem we will limit to the values which are standard and which are taken. We will not go for the reality. Reality could be about 300 hours or 275 hours or so. But then using this, if we take the current value of the fuel cost which we have given on the basis of the current value, say at July 2018 in Indian conditions, the labor cost and the oil cost and fuel cost, if you add together, then these values are there. Now, we need to take these values. So, using these values, the field capacity of the machine is here, which is already given to us. Per hectare labor cost works out to be then rupees 93 per hectare. Okay. Next, the per hectare fuel and oil cost will be calculated. How do you calculate that? In fact, for that also the ASC has given already a equation. And why we follow this? Because these are the standard equations which are being all over standards and which are being used all over by the scientists and engineers for finding out the specific fuel consumption. And this is the expression which is given here. Now, where the ratio of actual to maximum power is given by x here in this. Rest LC is the equation. So, this value as we have taken found to be 0.39. Now, using this value of 0.39, then what we get here is something of the order of this 0.582 liter per kilowatt hour. Now, the hourly consumption is then given as 15.83 liter per hour. Now, depending upon what is the type of the machine, what is the total horsepower of that, this value may change. This is a calculation which is on the basis of certain assumptions of the cost and the existing cost, etc., and the calculations which are say ratio of actual and maximum power, which we have taken as 70, and this is the actual which is to be used in kilowatt. So, using this value, it comes to about 16 liter per hour. Now, this value may change. This value will change depending upon the conditions what you have, depending upon type of the machine which you have taken. This is actual, but then actual machine could be about more than 75 horsepower. Then in that case these values will change, but it gives only an idea that how much hourly fuel consumption will take place. In fact, the oil consumption also will be there accordingly. So, we need to calculate that as well, how much of oil will be required. This talks of only the fuel consumption. So, per hectare fuel cost that way then comes out to be about 2696 per hectare. And the estimated oil consumption rate, as I said, that we need also to know about this, because the machine will require this oil when it is being used for a long duration of time. There will be requirement of this oil for lubrication and other aspects which are there in the machine at different locations. So, it works out to be here we are talking of so much the per hectare fuel cost, which comes out to be 2696 per hectare. Mind you, these values which are given, a representative value we have picked up and want to show you. These are not the values which will remain constant always, but then what you have to understand is that these values are in certain assumptions. So, as an engineer, when you are going for it, you will have to consider the data given, the conditions of the machine, the availability of the machine, and your own condition of the cost and the shelter or whatever that you have at your disposal. So, you have to consider all these things, then only you can come to the per hectare cost of the machine. Now, per hectare cost of oil, of course, as I said, per hectare is something of this amount. So, we have taken rated power to be 70 kilowatt, that has, as I said earlier. Now, we using this, we are getting fuel cost as well as oil cost. So, now let us see what else is required, because we are looking for the total cost, ownership cost of this particular equipment. The purchase price is corrected for 3% inflation rate, that is adjust price. Well, when you are talking of the interest rate, when you are talking of the machine, what you have purchased, and then you are talking of correction inflation rate. So, changes in inflation rate depending upon what is the which year you are talking of and all that. So, a very big figure comes at this point of time, which you may check if there is any mistake anywhere. Well, we are all with all humble this thing, we will accept that, but we hope that we have in a position to be a correct value that is given over here. But then all apologies for any mistakes in these calculations, although we hope there will not be, but then if there are any, we are ready to accept that and we correct if at all. Now, accumulated repair and maintenance cost for the 10 years use of the machine at only 200 hours per year, which I said that could be varying, it could be varying a lot. And for that you can use the same data of ASA, and this is given as CRM by PU. You know what CRM is the accumulated repair and maintenance cost, and PU is known to us already earlier. Then RF1 and RF2 talks of the repair factors from ASA data. So, repair factors RF1 and RF2, these values can be taken to be this from this data. So, assuming this, the CRM or the accumulated repair maintenance cost works out for this machine works out to be about this much value. So, again you can see that the calculations you may check. Well, harvesting at a rate of actual field capacity, now we have talked of say total in the life of this machine comes to be about 2000 hours. The combined harvest about 940 hectare, well, could be about 1000 hectare or so during its economic lifetime. Yes, it could be, because as I said, we are not talking of only 200 hours, it could be slightly more than that. So, if you safely, even if you take 1000, so you will get a very decent value of the total rupees per hectare, which comes to be for repair and maintenance cost. So, total per hectare operating cost excluding timeliness penalty cost of a wheat combine is given as this much here. Now, this is a cost which has been a consideration which has been considered with excluding the timeliness cost. Now, remember that when we consider this, we do not exclude this, but when we are excluding, this is what it is. So, as an engineer, you must be careful about all the parameters that I have talked of from right from the beginning to this point, as to what are the parameters to be considered, what values to be taken, which size of the machine to be taken for a particular operation, etc. So, you need to look into this. Now, with these two lectures of part 1 and part 2, what we have tried to explain to you is how do you select machines. As I told in the previous one, that selection and management, these are two important parameters. When we are talking of selection, we are talking of what concepts to be followed in selection, and then management. You can think of, if you go for simply calculations on a basis of the capacity of a machine, then you may find that about 3-4 units of tractor, 3-4 units of transplanter and certain machines, and the cost of that will be quite high. And in fact, that is not the way of the way engineers look into it. Engineer must look into the economics of the whole management, what selection he should take so that it is manageable and it is worth having those system, because we are trying to talk about a particular model. If somebody has 20 hectare land and he is thinking of a crop rotation of paddy, wheat and green gram, then what should be the machines. And in the second part, we have tried to look into what are the different costs which come. So, accordingly you have to work out the cost of those machines also which you have taken for your analysis, because the moment you have a 20 hectare land and if you think of a high ton capacity of production, you will have larger and larger amount of production, and say income will increase, and then you would like to roll back the money back into this and have increase in area. And once you have from 20 hectare to about 100 hectare and beyond and all that, then you will have to think of increasing the machines. You may have to think of even storing of the grains, etc., and then maybe processing of the. So, you can think of a total agri-system model where we can consider about the equipment to be required, management of the equipment, then produce, and then storing of the produce, then processing of the produce, then marketing of the produce. Every gamut of information that has to be looked into has to be considered when we are thinking of selection and management of machines. Well, I think this way I have tried to give you a sort of a overview of how should you select a machine or a group of machines for a certain given hectare area, and what management practices you should consider. Well, this will help you in solving some of the problems, and I know that there could be some relations, some situations where you may not be in a position to come to a conclusion, but then I hope that you will be able to follow this. And if you have any questions which we can always answer at some point of time during the process of understanding this, we will be ready to help you out. And I think I would like to close this here. Thank you very much.